Welcome to the Math Channel. I'm Alex Kay, and today we are discussing child geniuses, starting with Mr. Robert. Welcome, Robert.
Hello, Alex. Thanks for having me here today.
Robert, according to Sigma Magazine, your rise in math fame began in 7th grade. Weren't you always this good at math?
Well, no, I was actually struggling for the longest time.
So, what changed your mind about math?
The number devil, of course.
Who is the number devil?
Oh, well, he's short and red and kind of mean.
No, I mean, who is he?
Oh, the number devil comes to me in my dreams. He teaches me all this cool stuff about math and numbers.
Are you saying that these devil dreams are what made you so proficient in mathematics?
No, he's not a dream, he's real. He just visited me in my dreams and showed me all this cool stuff.
Oh, I see. What did the number devil show you?
Do you have a piece of gum?
Sure. Why do you need the piece of gum?
Well, how do you expect me to explain how many numbers there are?
Infinity?
Yeah.
Okay, here's some gum. Alright, now, what does a piece of gum have to do with infinity?
Well, I have one piece of gum, or 1 over 1. But if I wanted to share it with you, it would be 1 over 1 plus 1. And if I wanted to share it with more people, like the camerawoman and the director, it would be 1 over 1 plus 1 plus 1 plus 1. Each time you add a person to the equation, 1 is added to the denominator.
Okay.
Well, you could keep dividing like that till the cows come home, like forever, and you'd still have a piece of gum for everybody. It would get really tiny, though.
Infinity from 1. Very interesting. What else did you learn in your dreams?
Triangle numbers, logs, the number triangle, and much more.
To think that one boy could really learn all that in a dream. Now, Robert, tell us about triangle numbers.
Triangle numbers are numbers that make up a triangle. For example, 1, 3, 6, and so on and so forth, till the cows come home.
Interesting. But what happens if I want to know how many dots there are in, say, the 37th triangle?
I'm glad you asked. There's this cool formula that the number devil taught me that can be used for triangle numbers. Simply multiply the number of the triangle by 1 plus itself, then divide all that by 2.
That does seem pretty helpful. So, for the 37th triangle, you would multiply 37 by 38, and then divide that by 2? Then that would give you...
Exactly 703 dots.
Now, this seems neat and all, but wasn't there another triangle you were going to tell us about?
Yes, the famous number triangle.
Do you mean Pascal's triangle?
That's not what the number devil called it.
I see.
First, you start at the top of the triangle with 1. Then, you add that 1 with the number next to it and write that below the both of them.
But there's no number next to the 1, correct?
Exactly, so we treat that as 0. So, as you can see, we now have 3 1s. Do with these 2 bottom ones the same as you did with the top one to get another row of the triangle.
So the next row would be 1, 2, 1, right?
Exactly, followed by 1, 3, 3, 1.
This is cool and all, but what more can we do?
Well, you see, each row has a name, starting with the top of the triangle as row number 0. When you raise 2 to the power of the row number, you get the sum of that row.
I see. So the sum of the third row would be 2 to the power of 3, or 2 times 2 times 2, or 1 plus 3 plus 3 plus 1, which all equal 8.
Yes, that's right.
What are some uses of this number triangle?
The number devil said people use it for finding sums. Today it's used for probability and much more.
Fantastic. Now, Robert, tell us about your forgotten night.
Funny story, actually. I was being interviewed by that guy, Hans Magnus Enzensberger. I forgot about one of the dreams. We were in the middle of the forest with nothing around but a log cabin. I went inside and the number devil was there, of course.
Why did you go to a log cabin?
To talk about logs, of course.
Do you mean wooden logs or logarithms?
I mean logs as in exponents.
Oh, even better.
Yep.
What took place in this dream?
Well, it was the night before my test on logarithms. Mr. Bockel, like usual, didn't do a very good job of teaching us.
Who is Mr. Bockel?
He was my math teacher a few years ago, but it was the number devil who taught me all about logs.
What did the number devil say about logs?
Well, the number devil said that to understand logs, you need to understand hopping numbers, or exponents. Exponents are going to look like this. They tell you to take this number, the base, and multiply it by itself this many times.
That's right.
Okay, if you have a number, any number, let's say 2, that's your base.
Okay.
It tells you how many times to multiply it. If you had 2 to the third power, you have 2 times 2 times 2, which equals 8.
Okay, can you explain what happens when when its exponent is 1?
With exponents of 1, it will equal your base because it is just that number one time.
Okay, I understand. But what about 0? Can you have an exponent of 0?
Of course, if the exponent is 0, the answer will be 1 every time,
And why is that?
because each number is multiplied by an invisible one. When you take away all the other numbers, you're left with simply 1 as the answer.
Can you explain the relationship between logs and exponents?
Well, you know how exponents work, just look at this picture. We can see a log and 2 blanks.
So what does it all mean?
Let's say you had log base 10 of 10. The base is 10, and we need to figure out to what power we need to raise 10 to get 10. Now obviously, this is just the first power.
So if you have log base 10 of 100, the answer would be 2.
Yes, that's correct.
So what would happen if you had log of 1?
Well, as many people know, any number raised to the 0 power is automatically 1, so the answer would be 0. But there is also common logs and natural logs.
What are common and natural logs?
The common log is base 10, and the natural log is base 8. In fact, the common log is so common that when you use it, you don't even have to write a base.
That makes sense. But I have a question. What are logs used for?
That's a good question because many people don't know. Many things in life are measured on logarithmic scales, so they're actually very useful.
What are some applications of logarithms in everyday life?
The Richter scale, the pH scale, and the magnitude scale for star brightness.
Wow, so logs must be pretty useful, huh?
Yes, very much so.
But you still didn't answer my question. What exactly happened on the last night?
Alright, it was very strange at first, as when I first woke up in the cabin, the word log was written all over the walls. I thought it was somewhat redundant to have a log cabin labeled over and over with log, but that's just a number double for you.
That does seem somewhat odd. What happened next?
That was when the number double appeared. What have you done to this place? I asked him, since it was obvious that he used that bothersome pencil of his.
This sounds quite interesting. Please go on.
Well, afterwards, he said he knew about my logarithm test and wanted to make sure I knew what I was doing. Obviously, I didn't know a thing. He asked me what logs were. I gave him this blank stare, and I didn't know what to do.
So, how did he help you figure everything out?
Almost the same way I just showed you, it just took a lot longer. He had to show me what each piece meant about bases and how to solve them. As I mentioned before, we had already discussed exponents in the previous night.
Does the number double ever talk to you about things other than math?
Not really, because he really can't talk about anything else.
How do you feel about the number double?
I joke around, but he is a really great friend and teacher. I don't know where I would be without him.
That's incredible. Thanks for joining us here on the Math Channel. We'll see you next time.